Okay. So now we said symmetry property for a real valued sequence. Now I said sequence is real and even sequence. Real and even sequence. So what do you mean by real and even sequence? Real and even. So x of n is real and even. So a function is even if f of minus n is equal to f of n. So I can say in this case the sequence is symmetry sequence. So I can say x of n is equal to x of n minus n. So if I said x of n is real valued even sequence, then I can say x of n is equal to x of n minus n. Even sequence. So when my sequence is even, that means my odd component of the DFT becomes 0. Odd component of the DFT becomes 0. So I can say x of k is equal to only x of rk. This ik, x of ik will become 0. If it is even sequence. So since it is a real, then xin is also 0. So I can say x of k is nothing but a x of rk, only the xr portion. So only it will be x of rn into cos 2 pi by k into n. X of rn, if you see the expression I will show. So x of rk, x of r and x of I. So this portion will be 0, only this portion will be there. So I can say x of k is nothing but a, this is the DFT of the sequence. So if my sequence is real and even sequence, then DFT is reduced to this one only. So there is no imaginary part, only real part, which is equivalent to discrete cosine transform. Later on we will come to that part. Okay. So what is the relation, discrete cosine transform relationship, will come to that part. Similarly, if I take the inverse DFT of this xk, I will again get back the signal, which is nothing but a 1 by n x of k cos. Okay. So this is when the sequence is real and even sequence. Now sequence is real and odd sequence. So odd sequence means x of minus n is equal to minus x of n. So this is the condition for a odd sequence. If it is odd sequence, real and odd, so small x of in is equal to 0 and x of rk is equal to 0. Because if it is odd sequence, then x of rk will be 0. So if x of rk is 0, then if this equation, again go to this equation, x of rk is 0, so this part will be not there. X of only ik will be there, and then also this part will be not there. Only this part will be there. So minus xrn sine. So minus xrn sine. Okay. Similarly, if I take the IDFT, I get the x of n sequence. Similarly, if my sequence is purely imaginary, so x of rn is equal to 0. Put that, find out that expression. So x of rk will be this one and x of ik will be this one. So x of k is equal to nothing but a x of rk plus j x of ik. Now if you see, what interesting thing is that if it is sequence is purely imaginary, then real part becomes sine component, which is odd, and imaginary part even component. So sine theta is an even odd function and cos theta is an even function. Because of sin minus theta is equal to minus sin theta. Cos minus theta is equal to cos theta. So, cos is an even function and sin is an odd function. So, now see that generally real part is an even function, imaginary part is an odd function. Now, here if the sequence is purely imaginary, then I said the real part of the Fourier transform become odd function and imaginary part become even function. Now, if I say if my input in is odd, so if xin is odd, odd means if it is input is odd, then the frequency domain even function becomes 0. So, that means xik becomes 0. Then I can say xk, so this part is 0. So, xk is purely real part. Now, if my xin complex, but the function is even, if the signal is complex even signal, then I know the odd part becomes 0. So, this part becomes 0 in frequency domain. So, this part is purely imaginary. So, for an imaginary sequence, if my sequence is odd imaginary, then frequency transform is purely real. If my sequence is even imaginary, then my frequency transform is purely imaginary. Is it clear? So, for an imaginary sequence. Now, if it is a, so if for imaginary sequence you know, for real sequence you know, for a real, even, real, odd sequence, all I covered. And I have covered also for a real sequence the symmetry of in magnitude property. Okay. Now, I goes to the circular convolution. So, you have heard about what is circular. So, how this circular convolution come into the picture? Why it is used? What is the purpose? Why I call about circular convolution? You know the linear convolution. That means when a signal is input to a system, output of the system is nothing but a linear convolution of signals and system response. So, system's impulse response Hn. So, if I have a linear convolution, if Xn is my signal and Hn is my impulse response of a system, then output of the system is nothing but a linear convolution of x of n, h of n minus k, x of k, h of n minus k. So, you know that n equal to k equal to 0 to infinity or minus infinity to infinity. So, that is a real linear convolution. Now, I come to the circular convolution. Why? So, interestingly, what you can observe that, suppose I have a sequence x1n and I have another signal x2n. So, I have a digital signal x1n and x2n. So, if I take the Fourier transform of x1n or DFT of n point DFT of x1n, I get x1 capital X1k and I get DFT of x2n is given me the capital X2k. Now, if I say the product of these two x1 capital X1k multiplied by capital X2k, the product is another signal which is capital X3k. Let us say I multiply them and I get another signal which is X3k, capital X3k. Now, since all are in frequency domain, if I take the inverse DFT, IDFT of X3k, I should get back a signal which is X3n, time domain signal. So, let us say I take the IDFT of X3k and my time domain signal is X3m. because here I am using n, that's why I said sequence length is m. Okay, so m is nothing but a 1 by n, k equal to 0 to n minus 1, x3k e to the power j 2 pi k m divided by n. That is the inverse Fourier transform. Inverse IDFT. Okay. Now, I put the value of x3k, x1k multiply by x2k, and this will be e to the power remains same. So, x3m, now I put the value of x1k and x2k. x1k is this one, and so this one is this one, and this one is this one. Here I change the summation node. Here I take n, and here I take, instead of n, l, because two different signals. So, to distinguish them, I take l equal to 0 to n minus 1, x2l e to the power j 2 pi k l by n. So, instead of l, here I put l, and here I make n, whatever n is there. Okay. So, it is kn by n, it is kl by n. Okay. Now, if I see that, if I do the product, so I take the summation side, so I can say n equal to 0 to n minus 1 x1 n, and l equal to 0 to n minus 1 x2l, and k equal to 0 to n minus 1, and all e I put together, because they does not have a k. So, I can k sum can be only e to the power. So, e to the power 2 pi k m is positive, l is negative, n is negative. So, minus n minus l divided by n. So, this is my x3m. So, my x3m is this one, and k equal to 0 to n minus 1 e to the power j 2 pi k m minus n minus l divided by n. So, I can say the last part of the sum is k equal to 0 to n minus 1 e to the power minus j 2 pi k m minus or plus? This is plus, sorry. Plus m minus n minus l whole divided by n. Let's say a equal to this one, e to the power 2 pi 2 j 2 pi m minus n minus l is equal to a, except k. So, I can say it is nothing but a k equal to 0 to n minus 1, e to the, this part is a, so a to the power k is given. Because this expression does not have the k, so I said a to the power k is there. So, what is summation of k equal to 0 to n minus 1 a to the power k? So, if a equal to 1, then it is nothing but a 1 plus 1 plus 1 plus up to n minus 1. So, it is nothing but a n. But if a is not equal to 1, so that is an n dimensional series. So, it is 1 minus a to the power n divided by 1 by a. If a equal to 1, it is purely 1 plus 1 plus 1 plus up to n minus 1, k equal to 0 to n minus 1. So, n number of 1 is there, so it is n. Okay. Now, if it is not 1, then it is 1 minus a to the power n divided by 1 by 1 minus. Now, if I want to make this a equal to 1, when a will be 1? I want to make a equal to 1. When? If you see, what is a? A is e to the power j 2 pi m minus n minus l by n. So, if I said m minus n minus l is an integer multiple of n, so e to the power, let us say j 2 pi, let us say it is 2n by n is nothing but a e to the power j 4 pi, which is nothing but a cos 4 pi minus plus j sin 4 pi. So, which is nothing but a 1. So, a will be 1 when this m minus n minus l is an integer multiple of n. So, let us say I am writing down L is equal to m minus n plus L is equal to m minus n plus Pn. Now, if I put the value of L is here, m minus n plus minus m plus n, then this will be minus L, so minus Pn. So, I can say m cancel, n cancel, e to the power minus j 2 pi Pn. P is an integer divided by n, so n cancel. So, e to the power minus j theta is also cos theta minus j sin theta. Sin theta is 0, so cos theta is equal to 1. So, whether it is negative, positive does not matter. Now, if I say that, so what is the meaning of this? The meaning of this, that it is circularly shifting with a modulo of n. M minus n is a modulo of n. So, if m minus n is modulo of n, then this sum becomes n, elsewhere it is 0, because if a equal to 1, this is 1 minus 1 divided by 1, so it is 0. So, elsewhere it is 0. So, only consideration is that if L is an m minus n modulo n, then this sum, this e to the power term becomes n. So, this n will be cancelled. Now, L is equal to m minus n mod n. So, I can say this is nothing but a n equal to 0 to n minus 1, x1 n and x2 L. L is nothing but a m minus n modulo n. This expression is also an convolution sum. If I say linear convolution, y of n is, sorry, plane is not linear. What is linear convolution? Y of n is equal to k equal to minus infinity x of k h of n minus k. This is a linear convolution. This is also x3m is nothing but a convolution of x1 and x2, but it is a circular convolution. Convolution is circular convolution. So, what I can depict from this proof? I can say that if I have a two signal x1 and x2n, if I compute the circular convolution in time domain, the DFT of that is nothing but a frequency domain multiplication of the two frequency domain signals. So, if x1k and x2k in frequency domain I multiply, if I take the inverse Fourier transform of that, I get that x1n and x2n is circularly convolved. So, I can say the circular convolution between the two signals is nothing but an inverse DFT of multiplication of the frequency response of the two systems. Let us say, give an example. Let us say, I have a system which has an impulse response h of n, and I have an applied signal x of n. I get output y of n. How do I calculate y of n? The first procedure is y of n in time domain procedure is nothing but a linear convolution k equal to minus infinity to infinity x of k into h of n minus k. So, this is linear convolution. Directly I can calculate what y. What is the other way? I can say, let us say x of n has an DFT, discrete Fourier transform, is x of k, and h of n has a discrete Fourier transform which is nothing but a h of k. Now, if this is x of k and this is h of k, then y of k is nothing but a product of x of k into h of k. Then, if I say what is the IDFT of this one, is nothing but a x of k. IDFT of this one is equivalent to x of k circularly convolved with x of n circularly convolved with h of n. So, inverse Fourier transform of this product is equivalent to circular convolution of x of k and h of x of n into h of n. So, what is the meaning of IDFT of this one? IDFT is nothing but a y of n. IDFT of product is nothing but a y of n. So, this is the use of circular convolution. So, circular convolution. If I ask you what is the length of this yn, let us say xn is a signal of length is m and hn is a signal which is length is l. Then what should be the length of output yn? If L is less than m, then what should be the yn? Think on it. So, suppose I have one of x of n, input signal is let us say n is equal to 500 and let us say 600 points, and L filter response is let us say 50 points. Then what should be the DFT length in both the cases? DFT length both the cases must be more than 600. So, I will put 0 pad in here and make it 600 and then calculate. So, that I will come later on also, that what should be the length of this convolution kind of thing, or you also think on it, what should be the length of convolution of this thing. Okay. So, now give an example, circular convolution example. I will give an example, I will end this class. Okay. So, what is the example given? How do you compute the circular convolution? So, circular convolution, let us I have a signal x1n and I have another signal which is x2n. Okay. So, if I want to represent the signal in so x1n, 0th sample is integration is this one, and here also 0th sample integration is this one. So, if I want to represent in a circular sampling system, so how do I represent? Let us say I start with this is my 0th index. So, index is positive if it is rotate anti-clockwise. So, this is 0, this is 1, this is 2, this is 3. So, 0 value is 1, 1 value is 2, one sample is, first sample is 2, second sample is 0 and third sample is 1. Similarly, I can x2, 2, this index is 0, this index is positive, so 0 is equal to 1, 1 is equal to 2, and the second sample is 3, and third sample is 4. Now, what is x2 minus n? Index is negative. So, if I said clockwise index is positive, anti-clockwise index is positive, then I can say clockwise index is negative. So, if clockwise this is 0, this is minus 1, this is minus 2, this is minus 3. So, x2n, what is the value of x2 minus n? Is nothing but a 1, 2, so 1, 2, 3, 4. So 1, 2, 3, 4, 1 will be here. You know that. What is x2 minus n? Minus n, so I have said that I have a signal x2n which has 0th sample is 1, first sample is 2, second sample is 3, and third sample is 4. So, what is minus x2n? 0th sample will be 1, first sample will be minus 1 sample will be 2, minus 2 sample will be 3, and minus 3 sample will be 4. So, I can say x0 is 1, minus 1 is 2, minus 2 is 3, and minus 3 is 4. So, this you can put a minus. Minus 2, minus 3. Okay. So, this is x of minus n. Now, what I said, x of 3m is equal to, tell me, n is equal to 0 to n minus 1, x1 n into x2 m minus n circular convolution, circular sequence of n. Okay. So, now my length of DFT is 4. So, I can say x of 3 is m0, 0th sample. So, n equal to 0 to 3, x1 n multiply by x2 minus n. So, this is my x2 minus n and this is x1 n. So, it just multiply. So, 1 multiply with 1 get 1. This sample multiply with this sample 2 into 4 8, 0 into 3 0, 1 into 2 2. Then sum. So, it is nothing but a 1 plus 8 plus 0 plus 2 equal to 11. Okay. Now said, what is the value of x3 1? So, x3 1 is nothing but a n equal to 0 to 3 x1 n into x2 1 minus n. So, I want to make 1 minus n. So, x2 1 minus n. So, this is x2 minus n. So, if I want to shift one sample positive side, then I get x2 minus 1 n, 1 minus n. So, positive side means rotating this one in anti-clockwise in one sample. So, if I rotate it, then 0 becomes here. So, I can say x0 will come to here and x1 will, x of minus 1 will, this one will come to here. So, this one will come to here and this one will come to here and this one will goes here. So, I rotate it, rotate x of n minus n in anti-clockwise one sample. So, I get this one and this one is my x1 n. So, just product is nothing but this multiply this, this multiply this, this multiply this, and this multiply this. So I get 1 into 2, 2, 2 into 1, 2, 4 into 0, 0, 3 into 1, 3. So I get sum 2 plus 2 plus 0 plus 3 is equal to 7. Now what should be? Let's say I want to draw x2 2 minus n. So this will be shifted further this direction. So this one will go to here. So x1 x2 1 will be 2. So this will be 2, and this will be 1, and this will be 4, and this will be 3. Now then what should be the x3 2? Is nothing but this multiplied by this. So 3 plus this multiplied by this 4 plus this multiplied by this 0 plus this multiplied by this 4. So 8 plus 3, 11. Then x3 minus n, rotate it again. So then 3 becomes here, 2 becomes here, 1 becomes here, 4 becomes here. Then multiply again, you got x3. So x3 is nothing but x3 3 is nothing but 4 multiplied by 1, 4, plus 3 multiplied by 2, 6, 2 multiplied by 0, 1 multiplied by 1. So that way you can calculate one by one after another circular convolution. So this is the procedure for calculating circular convolution. Is it clear? Okay? Thank you.